Okay, so sorry about the last video. For number 15, it says the letters x and y represent rectangular coordinates. Write the equation using polar coordinates r theta. I remember that r equals x cosine theta, and y equals, and have that backwards, r sine theta. So yeah, I'm really trying to screw this up, guys. Okay, so x equals r cosine theta. There it is. So wherever I see x, I'm going to plug in r cosine theta squared plus 4 times r sine theta squared. Okay, equals 4. So if I do this, I get r squared cosine theta plus 4 times r squared sine theta equals 4. The only thing you can do is you can factor out an r squared to get r squared times cosine theta squared, I forgot to square that by the way, plus 4 sine squared theta, and that equals 4. Okay, that's it. Like, that's all you can do to that one. All right, number 16, let's move on. So 16 says transform the polar equation to an equation of rectangular coordinates, then identify and graph the equation. It says r equals 5. So if I'm going to graph this, and I'm going to grab a picture of it. So hold up. Boop. I'm going to go over here. Okay. Let's pull this down here. So if the radius is 5, I find the ring, which is 5, and I go all the way around, right? So right now, I know this is a circle. Okay? And remember that r equals the square root of x squared plus y squared, right? So we can say that r squared is equivalent to x squared plus y squared. Okay, so what I'm going to do is I'm going to square both sides. So r squared equals 5 squared. And if I do that, I get r squared equals 25. Now I can substitute in. So r squared is equivalent to x squared plus y squared, which equals 25. So this is the equation of a circle. Okay, let's do number 17. 17 says r sine theta equals 4. So again, I'm going to take a picture of this guy, and then we are going to graph it. Okay, so let me do that. Let's do this. Whoop, a little bit too close. Sorry, guys. Hope that's not making you sick. Okay, I'm going to pull this over here, and we're going to go forward. Okay, so remember that x equals r cosine theta, and y equals r sine theta. Okay, so I see we have r sine theta is equal to 4. I'm going to use substitution right here. I'm going to put y. So y equals 4 is a horizontal line. So I find the ring 4, and I'm going to put a vertical line in there. I'm going to put a horizontal line at 4. Okay. It's a little bit crooked. Anyways, it's going to be a horizontal line at the value of 4. Okie dokie. So that was 17. All right. 18 says write the complex number 2 plus 2i in polar form. Express the argument in degrees, round to the nearest tenths if possible. Okay. So they want this in polar form. And I need to deal with these two values here. All right. This is x, 2, and this is y, right? So what I'm going to do is I need to transform this into polar. So remember that we can find r and theta pretty easily. So let's go ahead and find r because I need that. So it is the square root of x squared plus y squared. So this is going to be 2 squared plus y, which is also 2. 4 plus 4 equals 8. So square root of 8 is r. Okay. And then we also need theta. So theta can be found by taking inverse tangent of y over x. And this was good for quadrant 1 and quadrant 4. Since 2 plus 2i is in quadrant 1, I can just use this formula and not worry about adding pi to it. All right, so my y value is 2, my x value is 2. So inverse tangent of 1 equals pi over 4. So now I have the angle as well. So I'm going to look at the formula sheet, and it says that z is given as r cosine theta plus I sine theta. Okay, so z equals, now I know what, and I forgot an r, like r sine theta I. Let's write it like that. So r sine theta I. Okay, so again, r is square root of 8 times cosine of pi over 4 plus r is square root of 8 times cosine of pi over 4 I, and I need to put in sine right there. There we go. Alternatively, I could have wrote this as the square root of 8 cosine of pi over 4 plus I sine of pi over 4. Okay, and that is z. Okay, so that is how I take the complex number and turn it into a polar number. And that's what they want you to do. So write the complex number in polar form, and I just did that. So that's 18. I'm going to stop the video and pick up with question number 19 in the next one.